Good day, friends. Let's try to solve this problem, which is about torque, and I hope that this problem will teach you some ideas and some hints how to work with torque. So the problem goes like this. A ball with a mass of 3 kilograms rests on an inclined plane that makes an angle of 60 degrees with the horizontal. So this alpha, as you see it right here, this thing is 60 degrees. The equilibrium of the ball is maintained by friction with the plane. Yeah, it's just right here, friction with the plane. And by the tension of a string, which is right here. We definitely know that here we have a tension force of a string. One end of the string is attached to the top of the ball, and the other end is attached to the top of the inclined plane. So it's just right here and here. It's not the top of the inclined plane, but it doesn't matter, to be honest, because if our situation was just like this, if it just ended here, it doesn't matter, because this thing can be just infinite and it changed nothing. Okay, and find the tension in the string if the string is horizontal. And definitely we see that this thing is already here. Yeah, it's already drawn horizontal, which means it is correct. Okay, so what do we have here? This is a problem about torque, which means that we definitely have some forces which are trying to rotate our ball, but as it was said before, where the equilibrium of the ball is maintained. This phrase is really important because it means that our ball is not moving at all and it is not being rotated. Okay, it tells us many things. For example, that sum of torques equals 0 and sum of forces equals 0 as well. Okay, so let's draw some forces. As I said before, this is a friction force, yeah, definitely, and this is a tension force. What else do we have? Let's draw all the forces that we have. We have here mg, right, weight, and here we have our normal force. What else? Yeah, I believe that's it. Those are all the forces which are acting on our ball, but only 2 of them are trying to rotate our ball, because normal force and mg are passing through the center, and if we choose that point, this particular point, as a point of pivot, it means that normal force and mg just cannot rotate, which I am definitely going to do because it's pretty comfortable. However, as I've said in the previous video, the distance from the pivot to the force, those two have to be cross product, which is perpendicular. And as we can see it right here, this thing and this thing, friction force and tension force, which are trying to rotate our ball, both of those things are perpendicular, which is pretty convenient because we don't have to break those two into components, because their real forms without components are already perpendicular. Okay, so we have this formula, torque equals F cross product R, right? And we definitely know what? We know that sum of torques equals 0, sum of forces equals 0, because equilibrium state, it is not being rotated, it is not moving. Okay, only 2 torques are here, as I've said before. Yeah, let me choose some green or just violet. Torque 1 is here and torque 2 is here. So normal force and mg have no torque on our object because they are just passing through the pivot, right? Which means that those things, those forces cannot work with the torque, right? Okay, only 2 forces which are trying to rotate our ball, and both of them are opposite to each other. So this thing is trying to rotate here, and this thing is trying to rotate here. This is clockwise, this is counterclockwise. Okay, so which means that we also know that sum of torques equals 0, and we know that those two are opposing each other. It means that torque 1 minus torque 2 equals 0, because those two are opposing each other. And definitely it means that torque 1 equals torque 2. Yeah, just let's take this thing and move it here, and it just becomes positive. Okay, good. And I know that torque 1 is just tension force, and it is just radius distance away from the pivot, and this is also radius distance away from the pivot, which is just tension force multiplied radius equals friction force multiplied also radius, because both of them are in equal distance from the pivot. And I can just take this away because both of them are equal to each other. So tension force equals friction force. Okay, that's good. However, it's not the end, yeah, because I'm not told anything about a friction force. I'm just told that we have a friction force, but we don't know its value. However, we need to know its value. Okay, so what do we have? Let's work with this thing. Sum of forces equals 0. So let me choose some different coordinate. Yeah, it's not just straight, it looks like this. This is my y, and this is my x. Yeah, that's why I have to do what? I have to just break this mg into components. It looks like just downside and here, yeah, and if I just draw the ending right here, this is 90 degrees, this is just 90 minus alpha, then this entire part is just alpha, right? Because this entire part, this entire part is just 90 degrees, right? And if this huge thing is alpha, it means that this small thing is also alpha. Okay, good. We have just proven that this thing is alpha. That's why it has to be mg cosine alpha, because it is adjacent. This thing, mg sine alpha. Okay, good. What about normal force? It cannot act horizontally because it is totally vertical. Friction force is already there. What about tension force? We have to break tension force into components because we need this kind of coordinate system. And that's why my component of the tension force will look like this, parallel to friction force. And I definitely know that if this thing is alpha, then this thing is also alpha, because let me show you, this thing is parallel to this thing, and this line is parallel to this line. It means that those lines have the same angle. It's here. Okay, let me show you something. Let me take all of these things and copy it. And I'm going to show you something. Let me take these things and get me rid of extra lines which are not important to me right now. Yep. And this thing as well. Yeah, good. So we have this kind of rope and this kind of plane. What if I just take and rotate this thing a bit? Something like this. Yeah, let me put this angle, this plane, as a horizontal one. And if I just pull this rope like this, yeah, like here, it means that I can say definitely that I'm trying to pull this rope at the same time to the right and down, right? And I can definitely say that this is just 90 degrees. This is alpha, which means what? My tension force is my hypotenuse. This is hypotenuse against the 90 degrees. This is my adjacent part, yeah, and this is my opposite side. So which means that this component, yeah, let me take these things away again, and if this thing is my tension force, yeah, this red vector, then this adjacent component is definitely just t cosine alpha. Yeah, and this is just t sine alpha, but this is not important. Why? Because right now this thing becomes t cosine alpha, and this is exactly what we need. Right now, let's draw forces which are acting horizontally. Sum of forces equal 0, which means what? Yeah, we have t cosine alpha, which is trying to pull us upward, t cosine alpha, and we can definitely see that friction force is trying to help it, plus friction force. And mg sine alpha is trying to oppose it. It tries to pull it down, minus mg sine alpha, and all these things equal 0. Yeah, I hope that I have not forgotten anything. And yeah, I believe these are the forces which are acting horizontally. And what we can see here, that we know that our friction force equals our tension force. It is here, and I can just write it like this: t cosine alpha plus tension force minus mg. I can just move this mg to the outside. It becomes just mg sine alpha positive. And I can take t as a common factor. It becomes cosine alpha plus 1 equals mg sine alpha. And if I just take this thing and move it here, it will become just t equals mg sine alpha divided by cosine alpha plus 1. Yeah. Okay, this is our answer, and this is the correct answer. I hope that everything is clear to you, and if not, you can definitely write me privately. This is the end of the video. Thanks, goodbye.